All right, so we've all gotten pretty used to AI that can chat with us, write an email, or even whip up a wild image. But what if AI could do more than just respond? What if it could actually act on its own? Well, that's the world of AI agents. It's the next huge leap for artificial intelligence, and today we're going to dive deep into how they work, where they're being used, and, maybe most importantly, the massive challenges we're facing in building them right.
You know, for the last few years, AI has kind of been like this brilliant oracle you could consult. You ask it a question, it gives you an answer. You give it a prompt, it generates a picture. But the cutting edge of research is pushing way beyond that. We're seeing this fundamental shift from a passive AI that just talks to an active, autonomous system that actually does.
And that right there is the core idea. The whole point is to build systems that can perceive the world around them, map out complex plans, and then, this is the key part, actually execute those plans to achieve a goal. So we're moving beyond just getting information and into the world of taking real action.
Okay, so let's start with the basics. What exactly is an AI agent? To really get why today's agents are such a big deal, it really helps to see how far we've come. From the very first kind of clunky AI systems to the incredible reasoning agents that are starting to emerge right now.
So here's the formal definition from the research. The words you really want to lock on to are autonomous, perceive, reason, and execute. Think about it like this. A simple program is like a calculator. It only does exactly what you tell it to. An agent, on the other hand, is more like a personal assistant. You give it a big, vague goal, and it figures out all the messy little steps to actually make it happen.
And this contrast is just massive. Early AI from way back was brilliant, but only in a super narrow way. It followed these very strict hand-coded rules. If this, then that. That meant it was incredibly brittle. You throw it a curveball, anything unexpected, and the whole system would just break. Today's agents, they're the total opposite. They learn from data and from interacting with the world, which means they can adapt to the messy, unpredictable environments we actually live in.
So, how in the world do these things actually work? Let's pop the hood and take a look inside the agent's mind. It really comes down to 4 core components that are all working together. Yeah, the best way to understand a modern AI agent is to see it as a system built on these 4 fundamental pillars. It's not just one giant algorithm. It's more like a team of specialized modules that are in this constant loop: reasoning, remembering, and interacting with the world.
First up is planning. This is basically the agent's cognitive engine. It's the part that thinks ahead. So if you give it a really complex goal like, hey, organize a team trip to that big conference, the planning module is what breaks that down. It says, okay, step 1, find flights. Step 2, book hotels. Step 3, register all the attendees, and so on.
It does this through a really cool process called Chain-of-Thought reasoning. The agent literally talks itself through the problem, step by step. For that conference trip, it might think, okay, first I need a list of everyone who's going. Got it. Next, I need to check for flights on these specific dates. After that, I'll find hotels near the venue. It deconstructs the goal, thinks through the steps, and builds a solid plan, pretty much like we do.
Next up is memory. And this is absolutely crucial for learning and for having any kind of context. It's got short-term memory to keep track of what's happening right now, like remembering the question you just asked, but it also has long-term memory to hold on to information from past interactions, so it can remember your preference for window seats on flights, allowing it to get smarter and more personalized every single time you use it.
Now, here's a real game changer. An agent doesn't have to know everything itself. That's where tools come in. Just like you'd grab your phone to use a calculator or search for a fact, an agent can call on external tools. It can browse the web for real-time information, it can run a piece of code to analyze data, or it can perform super complex calculations. This just dramatically expands what it's capable of.
And finally, there's perception. This is what connects the agent to the outside world. It uses different modules to process images, understand spoken language, and read text. Perception is what allows the agent to grab all the raw data it needs to even begin that whole cycle of planning and taking action.
So you put those 4 components together: the planning, the memory, the tools, and the perception, and they work together to create something incredibly powerful. Now, let's zoom back out and see where these agents are already making a real-world impact right now.
And this is not science fiction anymore, not at all. AI agents are being rolled out across almost every major sector you can think of. While fields like healthcare and finance are definitely leading the charge, we're seeing them pop up really fast in scientific research, in education, and even in entertainment. They're fundamentally changing how work gets done.
Let me make this a little more concrete for you. In a hospital, an agent might analyze thousands of medical scans in just a few minutes, spotting tiny, subtle patterns that a human radiologist might miss. Or in a science lab, an agent could automate all the boring, repetitive experiments, running simulations 24/7 to test new drug compounds. That could literally accelerate the pace of discovery by years.
So the potential is, well, it's obviously enormous. But having this much autonomy brings up a really critical question. As these systems get more and more powerful, more independent, how do we make sure that they're going to operate safely and reliably? Can we really trust them?
And that question brings us to the other side of the coin, the huge challenges that researchers are grappling with every single day. Because look, building a powerful agent is one thing, but building one that's trustworthy, that's another thing entirely.
And these are the big ones, the hurdles that keep researchers up at night. It's not just about safety and weird, unexpected situations. It's about explainability. You know, the black box problem. Can we actually understand why an agent made a specific choice? Then there's accountability. Who's responsible when one of these things messes up? And a huge area of research is fairness. How do we stop these systems from just learning and amplifying all the biases that already exist in our society?
Now, these challenges are significant for sure, but the research does point to a clear path forward. It's just a path that requires a much broader way of thinking about how we build AI.
And this might be the most important takeaway of all. Solving these problems is not just a technical challenge, it's a human one. It's going to demand collaboration between AI researchers, cognitive scientists who study the brain, ethicists, and policymakers, all working together to build systems that aren't just intelligent, but that are also fair and accountable.
The ultimate goal here, as the research makes really clear, is this. The idea is to create more capable, responsible, and beneficial autonomous intelligence. The aim is not just to build smarter tools, but to create true, trustworthy partners for humanity.
Which leaves us with this final thought to chew on. The technology of autonomous AI agents is at a massive turning point, and its direction, whether it becomes our most powerful tool ever or our greatest challenge, that's going to depend entirely on the choices that we all start making right now.